Hi everyone, today we're going to be talking about factoring special quadratics. Now I'm not feeling too hot, you might hear my voice a little different, so just bear with me if my handwriting is a little bit off and if I make some mental mistakes, okay? Let's get started. So this is what we have done already. We've talked about factoring this entire unit, okay? Now the general quadratic that we've been factoring is this. ax squared plus bx plus c. This is a general one. Now we started when a was equal to 1. Right? When a was equal to 1, we had something like f of x equals x squared plus, let's see, 4x plus 3. And we did the Lopez approach, right? We had x times x, 3 times 1. We cross multiply. We got our solutions. And then we said, let's step it up a notch. What happens when a is not equal to 1? So we introduced other equations, right, most recently, where we had something like 2x squared plus 8x plus 6. And we said that now, instead of having x and x underneath, we're going to have a 2x times x. And then over here, we'd have to deal with like a 3 times 1. And then we'd have to cross multiply and make sure that adds up to 8x. And over here adds up to 4x. And we got our factors. So here, a equals to 1. A equals to something other than 1. We chose 2. We chose negative numbers. We chose bigger numbers. We chose all possibilities. This is what we factored already. Today we're going to talk about special quadratics that deal with a different scenario. So what is a special quadratic? A quadratic is anything that has at least an x squared in it. So if we're looking at our general quadratic in standard form, put ax squared plus bx plus c. So as long as we keep the x squared, it remains a quadratic. Everything else can change, and that's actually what we're going to be talking about today. What happens if we remove one of these terms, like the bx or the c? It's still a quadratic because it keeps the x squared. It's still a parabola. It still makes the u shape, but by removing the bx term or the c term at the end, it changes it to a special case. And these are the two special cases we're dealing with. We have f of x equals, let's say we have ax squared plus c, where we remove the bx. This could be plus or minus c. This could be a positive or negative c. And we could also have another type of quadratic where we remove the c value. So we have like an ax squared plus bx. So in this case, we are missing the b term, the bx in the middle, and in this case, we're missing the c term in the end. How do we factor both of these scenarios for these special quadratics? And that's what today's video is about. Okay? It's important that we know where we're headed and how this is different from what we've done before. Okay? We can still do all of this with Lopez approach, and I will show you Lopez approach for both scenarios to begin with, but then I will show you some tricks and some things you can do because these are special quadratics, some faster things we could do so we don't have to waste as much time. So here we have x squared minus 9. Notice how we don't have a bx term in the middle. So we can always add it. We can always just say f of x equals x squared plus 0x minus 9. If I wanted to do Lopez approach, this is what I would do. I would include a 0x in the middle because we technically have 0 x's, right? It takes me back to my 7th grade self when I had 0 x's. Anyway, so if we have a 0x, we can continue following the Lopez approach, and we can make our 3 columns and have x times x, and over here we would have 3 times negative 3. The reason why I have to choose the same number is because when I cross multiply, it has to cancel the 0. So I'll never do 9 times 1 because 9 plus 1 or 9 minus 1 will not cancel the 0. Anytime that I'm dealing with this scenario, I'm going to be dealing with the same number because that's how they're going to cancel each other out. And that's how I'm able to get a negative 3x and a positive 3x to cancel to get to 0. So what are my factors? My factors are horizontally x positive 3 and x negative 3, which results in x plus 3, x minus 3. Okay? So all I did here is I introduced the 0 term that we were missing, and I found numbers that when they cross-multiplied, they added up to 0 because we don't have anything in the middle. Let's try another one. Here we have x squared minus 36. So I'm going to do f of x equals x squared plus 0x minus 36. Again, because I am missing that term in the middle, I put a 0 for a placeholder. Underneath these columns, I have x times x. And on the right, to get 36, there's 3 times 12. Right? There's 6 times 6. There's 36 times 1. There's 4 times 9. With one of these being negative. And I'm always going to choose, when I'm missing the 0 in the middle, I'm always going to choose the one that's identical numbers, where one of them is positive and one of them is negative. Because that's the only way that when I cross multiply, negative 6 times x gives me negative 6x, and 6 times x gives me positive 6x. When they're opposite and identical, they cancel the 0. So my solution, or my factors, are x positive 6, x negative 6. Sorry. Okay, so here's the trick that I want to show you. We call this difference between two squares. Why? Because this is a square, x squared, and this is also technically a square as well. 6 times 6 gives you 36. In the previous example, we had x squared minus 9. X times x gives you x squared, and 3 times 3 gives you 9. Whenever you have the difference between two squares, you can always just take the square root of the first term, giving you x. Take the square root of the second term, giving you 6. And as long as one of them is positive and one of them is negative, they will always cancel out to give you the 0. I'll show you what I mean in this next example. So I'm not going to use the Lopez approach here. If you want to use it, you can always put the 0x if you want in the middle. But I'm going to do that shortcut that I was just talking about. I'm going to take the square root of the first term, and I have f of x equals x and x, because I have two of them. And then I take the square root of the second term, which is 10. So I put 10 on one of them, 10 on the other. Now, in order for these two to cancel, to get a 0 in the middle here somewhere, right, to get a 0 here in the middle, I have to put a plus for one of them and a minus for the other. And that's the trick. Anytime that you're dealing with two squares, the difference between two squares where you're subtracting something that can take the square root of and the square root of, you will always get the same thing, except that one's positive and one's negative. That's how it will cancel. So let's try another as an example. Let's say that we have f of x equals x squared minus 25. So I got my x's. And then if you look at that 25, the square root is 5 times 5. So I make one of them positive and one of them negative. And that's my solution. Most of the time, like 99% of the time, whenever you don't have a 0x in the middle, whenever you're missing a term in between, like a bx term, you will have the difference between two squares. That is most of the time. I will show you later what happens when it's not a perfect square. What happens if you have like a number like 20 and you don't have a 5 times 5 or a 4 times 4? Right? What happens in the middle? Well, at that point, we would have to deal with decimals. We'll save that for another video, but you would basically take the square root, excuse me, and then you just have decimals here instead of whole numbers. I hope that's enough examples to show you the difference between two squares. Now let's talk about the possibility when we're missing the c term. Like here we have ax squared, bx, and there's a c term missing. Again, you can always do Lopez approach with all of the methods. And in the end, I'll show you a trick on how to save time for this. So let's add a 0 at the end. Adding a 0 doesn't change anything, but it does allow us to see that there's now 3 columns. On the left, I still have x times x. And on the right, you can really multiply anything to get 0. 0 times any number gives you 0. So I'm going to multiply this times 0 and times whatever number I want. Now, since I'm cross-multiplying, I am going to have 0x down here. What is 0x going to add up to give me this 2x? You guessed it right. A 2. 0 times 2 is 0, but when I cross-multiply 2 times x, gives me 2x. And now I can add this to get a 2x. So one of these terms will be x plus 0 and x plus 2. Now, because we're doing x plus 0, you can also technically write it like this. Because down here, x plus 0 is just x, right? The x plus 2 stays in parentheses, but adding a 0 doesn't change anything. So you can write the equation like this, where it's x plus 0, or most commonly, you will see it as just an x value. Let's try another example. Now, I'm going to do this without using Lopez's approach. You can always do that if you want. You can be loyal to my 7th grade self and just add the plus 0 because you really like the 3 columns. Instead of adding a plus 0, what I'm going to do is I'm just going to pull out what they have in common. So what do these two terms share in common? They both have an x, and they're both divisible by 2. We call that the greatest common factor, or GCF, if you remember from like middle school. They are both divisible by 2, so I'm going to pull out a 2x. I'm also pulling out an x because they both have an x value. By pulling that out, I'm able to put parentheses on the next part. Now what I'm basically doing here by factoring a 2x out of the equation is I'm doing the reverse of distributive property. I'm looking at what do I multiply this by times here to get 2x squared. 2x times x gives you the 2x squared. And 2x times what is going to give you 4x? Positive 2. Now I know that's probably like, what just happened? I prefer Lopez's approach much better than this. It's too confusing. Let's just do distributive property. Let's multiply this. 2x times x gives you 2x squared. And 2x times 2 gives you positive 4x, which is our original equation. Right? So when you factor it like this, you're really just saying 2x plus 0 and x plus 2. Or, as we said earlier, just 2x and x plus 2. Those are going to be my two factored forms. The most common factored form that you're going to see is this scenario down here. Let's try another one because I know this was probably confusing since this is the first time that you see what do they have in common. So here, what do they both have in common? I know they both have an x in common. So I'm going to take out the x. Let's just slow down a little bit. I'm going to have an x that I'm going to pull out of the equation. Now, what do these two also have in common other than an x? They're both divisible by 3. Right? If they're both divisible by 3, I'm going to take out a 3x out of it. So 3x times what gives you 3x squared? X. 3x times x is 3x squared. 3x times what gives you 18x? Positive 6. And those are my factors. That's my solution. So I'm basically factoring it out. I'm dividing the 3x term out of the equation. Again, if you prefer the other method, you can use it as well. You can always go back and just say, you know what, I like the 3 columns idea. Let's just do that instead. But no, notice how when you add a 0 at the end and you do your 3 columns, notice how here you have 3x times x. When you multiply something times 0, 6, right? Anything times 0 is going to give you 0. So I'm always going to have some sort of 0 term associated with my equation. And one of them is going to be a number. That's why one of them has a 0, right? 3x plus 0, and the other one has the number. And notice how by cross multiplying, I get 18x and 0x, which results in positive 18x. So my factors horizontally, right, are 3x plus 0 and x plus 6, which is what we said earlier. So you can always add this 0 term at the end. You can always add the 0 at the end and do your 3 columns like we did here. But notice how by adding a 0, one of the terms will always have a 0 included, like a 3x plus 0, always. And the other term will have the number, which is why it's always just easier, or not easier necessarily, but faster if you just factor out what they have in common. Here they both have an x in common, so I take out the x first. And here they're both divisible by 3. So I put a 3 out there first. 3x times x gives you 3x squared, and 3x times 6 gives you 18x, leaving you with these factors. Do you want to do one more example of this type? I bet you probably do, just because of how tricky or complex this can be. Let's try one last one. Now, I wasn't planning on doing one last one, but I can sense you by reading this, like by seeing you watch this video, I can sense that you might be a little bit iffy on this possibility. So let's do this. F of x equals 4x squared minus 16x. I was trying to change the color of this because it's turned into black. Let me see if I can change it real quick while we're talking right now. I can't seem to be able to edit the color of the background. Hopefully it doesn't bother you too much. Okay, let's just continue with this and we'll see how it goes for you guys. Now, what do these two have in common? They both have an x in common, right? They have an x, and they're both divisible by 4. So I pull out the 4 as well. Right? Whatever they have in common is going to be associated with that plus 0 that we're talking about. And next to it, it's just doing the reverse of distributive property, right? 4x times what gives you 4x squared? X. 4x times x gives you 4x squared. And 4x times what gives you 16? 4x times negative 4 gives you negative 16x. You can always check your work by doing distributive property, but those are your solutions. My solution is f of x equals 4x times x minus 4. Or if you prefer, with the 0, you can say 4x plus 0 and x minus 4 if you're doing the locus approach. As long as you know that these two are identical and interchangeable, you are good to go. Alright guys, I hope this helps with special forms of quadratics and what to do when the function is either missing a bx term in the middle or a c at the end. Right? This way now you're going to be able to factor any type of quadratic no matter the situation. If you want to rewind, press pause, copy the notes again, take time to process this information, and I'll help you as soon as I get back to campus. You guys are doing great. Let me know if y'all need anything, and as always, I'll calculate it.